Hello everyone, my name is and this is the explanation video for the Blender add-on named Modelcules as a chemistry project for my final year at secondary school. If you go to Add, Mesh, then you'll see that there's a new button here called Molecule. If you click on it, then this panel opens up and you'll see a ton of options there. I'll explain what they do later. For now, if you move the panel over, then there's an atom to be seen at the center of the screen. This is a carbon atom, and you could change this atom by going over here and changing the option from carbon to oxygen or nitrogen or one of these other options. For now, let's choose to use a carbon atom. If you then move your cursor off of the panel, that atom is placed. If you now open this panel and you go to Molecules, then you'll see that there are a bunch of options to change this atom. This carbon atom can make 4 bonds because there are 4 empties around this atom. By selecting one of the empties and by pressing Create Atom, a new atom gets placed just like that. You can tell that this is once again a carbon atom because the atom type was never changed. Let's say you want to create an oxygen atom, for example, then you change it to oxygen. You then select another empty and then click on Create Atom again, and thus an oxygen atom gets placed over here. And you can tell that these oxygen atoms are unlike the carbon atoms in 2 ways. Firstly, this oxygen atom can only have 2 bonds instead of 4 like with the carbon atoms. If you go to covalence, this panel over here, then you'll notice that the covalence of the oxygen atoms is 2 and not 4 like with the carbon atoms. Besides that, you'll notice that the color of oxygen is not the same as that of carbon, because if you go to the panel Color, here you'll see that the color of oxygen is red. And you could also change this to, say, for example, green or blue or another color. In case you do change its color, but you change your mind later on, you could press the button Reset to Default, and then it'll change back to its standard color. This works for any atom type, by the way. Knowing this, you could already make numerous molecules, but you'll notice that it's only making singular bonds. What if you wanted to create a double or triple bond? Well, at the moment it's only making singular bonds because we've got singular selected right here, but you could change it from singular to double or triple. So if we chose double, for example, then it'll create double bonds, and the same applies to triple bonds. We're going to go back to atom type for now, because you can choose from a selection of the most common types of atoms, basically. But if you wanted to create another atom type, you could choose to create a custom one. For this, you'll need to make sure that the covalence and the color correspond with what you're trying to create. So you could change the covalence to 3, let's say, and the color to green. That's how you create the atom. Say you made another custom atom, for example a yellow one with a covalence of 4, but you then wanted another atom like this one. Then it shouldn't be the most difficult thing to select the same covalence, but getting the exact same color might be a bit trickier. That's why you'll have to go to the material. And then you can take a look at the material's name. R has a 1, G a 10, and B a 0. You'll need to divide all of these by 10. And if you then go to the color, and then RGB, and you fill those in, then you'll get the exact same atom with the exact same material. Those are essentially the basics, but there are other features. Because if you open up the panel Other, then that's where you'll find all the other things you can do. With editing, you can change the atoms of your molecule, starting with rotating the atom. Here is where you fill in how many degrees you want the atom to rotate, and if you then click on this atom and you click on rotate atom, then the atom will turn that many degrees. If you wanted to delete an atom, then you can do that by pressing delete atom, and then the atom will be removed. If something were to go completely wrong and you wanted to delete everything, you can press delete everything, and everything will get removed, so you can start working on a new molecule. With the panel cyclic compound, you can create a cyclic molecule. You'll fill in how many atoms the ring should contain at amount of atoms. In this case, I choose 6. Then you select the 2 atoms which you want to use to form the base. And finally, you press create cyclic compound. With that being done, you can create the cyclic compound. Now that it's done, you'll find that there are indeed 6 atoms since we chose 6. Coming back to editing, if you were to decide that you actually didn't want a carbon atom here, then you can delete this atom as well. With completing, you can finish the molecule, starting off with the button hydrogen to empty slots. With this button, you can add hydrogen atoms to the empty slots. And afterwards, you can really finish the molecule with the button complete molecule. With it also comes the option prepare for animation. With that, you can prepare the molecule for animation. For now, I'm just going to turn that off so you can see how it normally looks. As you can see, it adds a rectangular prism around the molecule. And by changing this, you change the whole molecule. Now I'll just show you what happens when you select prepare for animation and you then press complete molecule. As you can see, nothing has happened to the molecule itself, but the atoms have essentially been separated from another. And if you want the bond in between to go away as well, then you can do that by heading over to shape keys and changing this slider. Say you wanted this hydrogen atom to be separated on frame 22. You could start animating here, but the atom will remain stuck to the molecule. And you don't want that. Hence you can go to the panel animation to fix that. So on frame 1, it'll still be stuck to the molecule, but it'll let go on frame 22. So you change end frame to 22. Frame step basically changes on which frames a keyframe is placed. So if it were 1, a keyframe would be placed every frame, and if it were 2, a keyframe would be placed every 2 frames, so on and so forth. If you now press bake the keyframes, then you'll see that the hydrogen atom lets go on frame 22. And this is pretty handy for animation. Take for example this animation which I made of the esterification of methyl ethanoate. Lastly, there are a few inputs which change how the molecule looks, starting with the ones you see in this panel, which are not located under display. Icosphere radius changes the size of the icospheres, but this is not relative to the size of the cylinders. Cylinder length changes the lengths between the icospheres, and if you set this value to 0, you get some pretty interesting results. Moving over to the inputs under display. These ones can be changed while you're working on the molecule. Icosphere subdivisions changes the resolution of the icospheres. Icospheres with a resolution of 1 won't look that good, but if you set the resolution too high, renders might take a bit longer because it's more to load in. Cylinder vertices basically does the same thing, but for the cylinders. Hydrogen size changes the size of the hydrogen atoms in relation to the other atoms. For 1, it's the same size, and for 0, there's no size at all. Cylinder radius changes the radius of the cylinders. And at last, cylinder distance changes the distance between the cylinders for double and triple bonds. In case you changed all these values but want to make it go back to normal, you can click on the button Reset the Default. Now for icosphere material. Smooth shading changes the smooth shading of the icosphere. Icosphere roughness changes the material's roughness for the icospheres. And same applies to icosphere metallic, except here it's the metallic. And if you want to return these to how they used to be, you can click on the button Reset to Default. Cylinder material does the exact same thing, only for the cylinders. And here there's also the option to change the color. So I hope this video helped. Now you should be able to get started making molecules, whether they be small or big. So yeah.